Hello and welcome to this channel, IntelliMaths, where we'll be taking you through solving mathematics problem in the most simplest form. Today, we will be treating this topic, number bases. Though this topic might seem like the most simplest topic in mathematics, but trust me, there are many people out there that still find it difficult to solve problem under this topic. I can remember when I was in higher institution, there are still some of my colleagues that have issues solving problems under this topic, number basis. So in this video, we're going to take you through how to do conversion from one base to another. In this video, we're going to cover base 2 to 10. Of course, we have more than that. We have up to base 16, which is the hexadecimals. And looking at number bases, we have the most commonly used base is the base 2, which is the binary system, base 8, which is the octal system, and the base 10, which is the decimal system. Base 2 is binary, base 8 octal system, and base 10 is decimal. These are the most widely used bases, and we use base 10 in our day-to-day arithmetic activities. So let's get started. But before we continue, make sure you subscribe to this channel, IntelliMaths, and follow our social media platforms, Facebook, Instagram. We are on Facebook, we are on Instagram, and TikTok at IntelliMaths. Problems on number system. Like I told you, on this video, we're going to cover how to convert number from one base to another and how to perform basic arithmetic operation. That is the multiplication operation, addition operation, subtraction, and division across all number-based systems that we have. But before we continue, I would like to explain a concept to us. Our arithmetic digit ranges from 0 to 9. Now, in base 2 number system, we have only 0 and 1. This is base 2. In base 3, we have from 0 to 2. This is base 3. Base 4, we have all of this. Base 5, the highest number in base 5 is 4. The highest number in base 6, this is base 5. The highest number in base 6 is 5. As you can see, if you count, you have 1, 2, 3, 4, 5, 6. Base 7, the highest number is 6. Base 8, the highest number is 7. Base 9, the highest number is 8. This is base 9, and this is base 10. We have from 0 to 9. So, which means in each number system, the lowest number is 0. The counting starts from 0. And the highest number would be the last number in that base system. Like base 2, we have only 2 digits, which is 0 and 1. In base 3, we have 3 digits, which is 0, 1, and 2, and so on and so forth. Now, let's look at how to convert number from one base to another. I want you to pay close attention to this explanation because that is the foundation, that is the bedrock. What we are going to learn now is applicable to conversion in any base. Now, the first example we are going to solve now is we're going to convert a number in base 2 to base 10. convert 10101 base 2 to base 10. Now, to do this, to convert from base 2, I want you to take note of something. Conversion from base 2, from any base to base 10, you are going to use this method that I want to explain to you. And conversion from base 10 to any base, you are going to use the long division method, which I'm going to explain in this video as well. Now, let's look at this. We have 1100101 is a solution in base 2. Now, like I promised, I am going to teach you in the most simplest form to solve mathematics problem, from basic mathematics to advanced mathematics. Now, to solve this, to convert this to base 10, look at this. We have how many digits? 1, 2, 3, 4, 5, 6. These are 6 digits in this number. Now, let us assign power to each digit. So we start from the very last one. We start from 0, 1, 1, 2, 3, 4, 5. And what are we going to do in this regard? Then we pick each number. We pick each number starting from here. That is 1. We multiply the number by the base, the original base, which is 2, then raise to power of the power we assign to each number, each digit rather. That is 5. Then we add it. We move to the next number, which is 1, also multiply by 2 and raise to power of 4. Plus, the next number here is 0, multiply by 2 and raise to power of 3. Then plus, the next number is 1, multiply by 2 and raise to power of 2. Plus, followed by 0, multiply by 2 and raise to power of 1. Then plus 1 multiply by 2 and raise to power of 0. Now, let's do the mathematics here. The right one, 2 raised to power of 5. I always advise my students, don't train your brain with using calculators. So this is the way you can be a genius in mathematics, because solving this simple and basic mathematics with your head consistently will make your brain develop the mathematics ability. Now, let's solve it here. 2 raised to power of 5 will be 2. 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, that is 32. Which means 2 raised to power of 5 will give us what? Will give us 32. Then plus 1 times 2 raised to power of 4 will give us 16. Plus 0 times 2 raised to power of 3 will give us 8. Plus 1 times 2 raised to power of 2 will give us 4. Plus 0 times 2 raised to power of 1 will give us 2. Plus 1 times 2 raised to power of 0 will give us, and in the law of indices. So when we get to indices, I will explain better to you. Any number raised to power of 0 will give us what? Will give us 1. Now let's continue with the mathematics. 1 times 32 will give us 32. Plus 1 times 16 will give us 16. Plus 0 times 8. Any number multiplied by 0, or 0 multiplied by any number will give us 0. Plus 1 times 4 will give us 4. Plus 0 times 2. Don't forget, any number multiplied by 0 will give us 0. 1 times 1 will give us 1. So let's do the arithmetic, and whatever we get is our final answer in base 10. 32 plus 16, that will give us 48 plus 0 is still 48. 48 plus 4, that's 52. Plus 0 is still 52. Then plus 1 will give us 53. And that is in base 10. So we now we just converted 110101 in base 2 to 53 in base 10. So that is how to convert any number base to base 10. Let's assume this is in base 3. We're going to follow this procedure to convert it to base 10. Let's assume it is base 8 here. We're going to follow this procedure to convert to base 10. Now, for clarity, I'm going to convert this 53 to base 10. 53 in base 10. I'm going to convert it back to base 2. And let's see if it's going to give us the same answer as we got here. Now, don't forget, when we converted this, our result was 53 in base 10. Don't mind, no matter. 53 in base 10. Now, we want to convert this 53 in 10 to base 2. Now, to do this, we're going to use the long division method, and our remainder will be the final result. Now, let's see, this is what I'm talking about. 53 divided by the base 2. Let's assume we want to convert from base 10 now to base 3. It will be divided by 3. Let's assume we want to convert to base 8. It will be divided by 8. Then we record our remainder in each division A. 53 divided by 2. That will give us what? That will give us 26. 26 times 2, that's 52. Then we have remainder of 1. 26 divided by 2 also will give us 13. Remainder of what? That's 0. 13 divided by 2 will give us what? Will give us 6. 6 times 2 is 12. Then we have remainder of 1. 6 divided by 2 will give us 3. Remainder of 0. 3 divided by 2 will give us 1. Then we have remainder of 1. 1 divided by 2 is impossible. That means we're going to write 0. Then we have remainder 1. If we now read, we read from bottom to top this way. It means our 53 in base 10 will be equals to 110,101 in base 2. As you can see, it is the same. We converted from base 2 to base 10 to give us this, and we converted this from base 10 to base 2 to give us this. Like I said earlier, this method is applicable to all bases. If you are converting from any base to base 10, you follow the method I used here. And when you are converting from base 2 to base, when you are converting from base 10 to any base, you follow this method. I repeat, when you are converting from any base, either base 2, base 3, base 4, base 5, and so on to base 10, you follow this method. And when you are converting from base 10 to any other bases, either base 2, you are converting from base 10 to 2, to 3, to 4, 5, and so on and so forth. You use this method. It is as simple as that. So we've treated 2 examples that way. Now let's go to example 3. Now we have we want to convert another number So that it won't look like we're doing magic from base 10 to base 10 to base 2. Don't forget, you use the long division method divided by 2 and you record the remainder. So 29 divided by 2 will give us, like I said, don't use your calculator, use your head. That will be 14 because 14 times 2 is 28. Then we have remainder 1. And 14 divided by 2 will give us 7, remainder 0. 7 divided by 2 will give us 3, remainder 1. 3 divided by 2 will give us 1, remainder 1. And 1 divided by 2, that is impossible. That means we have 0 and we have remainder of 1. When we read upward, we have 29 in base 10 equals to 11101 in base 2. That is as simple as that. Now, for clarity, I'm going to convert this number in base 2 back to base 10 and let's see how it goes. 11101 in base 2. Then that will be because don't forget, if we assign power from the back and starting from 0, we have 0, 1, 2, 3, 4. It's not compulsory that you do all this. So far you know what you're doing and you are sure of yourself, you don't put it. This is just meant for clarity and for basic understanding so that you know what has gone wrong here. Like what we did here, it won't be as if it's a magic or it's a rocket science. No, that's the essence of putting it. So far you know what you're doing, you may decide not to put the power. Now let's continue. This will be 1 multiplied by 2, which is the base. All right. Then raised to power 4. Then plus 1 times 2 raised to power 3 plus 1 times 2 raised to power of 2 plus 0 times 2 raised to power of 1. Then plus 1 times 2 raised to power of 0. That is 1 times 2 raised to power of 4 will give us, don't forget, you don't use calculator, it's very simple, 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. And 8 times 2 will give us 16. Then plus 1 times 2 raised to power of 3, that is 8. Plus 1 times 2 raised to power of 2, that is 4. Plus 0 times 2 raised to power of 1, that is 2. Then plus 1 times 2 raised to power of 0. Any number raised to power of 0 is 1. So let's continue with the arithmetic. 1 times 16, that will give us 16. Plus 1 times 8, that will give us 8. Plus 1 times 4, that will give us 4. Plus 0 times 2, that will give us 0. Any number multiplied by 0 will give us 0. Then 1 times 1 will give us 1. Now let's do the arithmetic. 16 plus 8, that will give us 24. 24 plus 4, that will give us 28. And 28 plus 1 will give us 29 in base 10. You can see we converted 29 to base 2. We got this answer. And we now, for clarity, we decided to convert our result back to its original base, and we still get it right. So it is as simple as that. Now, let's move further now, and let's trace other bases other than base 2. Now, let's convert number from base 8 to base 10. Let's convert 1264 in base 8 to base 10. Like I said earlier, when you are converting from any base, all right, to base 10. You're going to follow this method that I explained to you, the multiplication and addition method. This is base 8. Like I told you, this is what we did there. We assign power to each digit. 1, raised to power 0, raised to power 1, 2, and 3. Then you pick each number one after the other, multiply it by the base, and raise the base to the power assigned to the number. It's as simple as that. Now, in this case, it will be 1 multiplied by, what is the base? 8. Then raised to the power of 3 plus 2 multiplied by the base 8 and raised to the power of 2. Then plus 6 multiplied by the base, which is 8, and raised to the power of 1. Then plus 4 multiplied by 8, which is the base, and raised to the power of 0. Now, this is it. 1 multiplied by, what is 8 raised to the power of 3? It's very simple. It's something you can do. That will be 8 times 8 times 8. 8 times 8 will give us 64. So 64, you can do it. It's very simple. 64 multiplied by 8. This will give you 32. You write 2, you keep 3. 8 times 6, that's 48. Plus 3, that's 51. That is 512. It means 8 raised to the power of 3 will give us 512 plus 2 times 8 raised to the power of 2 will give us 64 plus 6 times 8 raised to the power of 1 will give us 8 plus 4 times 8 raised to the power of 0 will give us 1. Okay, let's continue. 1 times 512 will give us 512 plus 2 times 64. You don't need to use calculator, just come to your playground. Let me put it that way. So 64 times, that is 4 times 2, that is 8. And this is 12. It gives you 128. So 2 times 64, that's 128 plus 6 times 8, that will give you 48. 4 times 1 will give you 4. Now let's do the arithmetic. 512 plus 128. Come to your playground again to do it. You don't need to use calculator. When you are doing things like this consistently, your brain will get used to it. And trust me, with time, you won't need to be doing all this before you say answers to basic mathematics operations like this. Now, 512 plus 128. 8 plus 2, that is 10. You write 0, you keep 1. This is 3 plus 1, that's 4. And this is 6. That's 640. So you add 48. Then you have 688. Then add 4. This is 12. You keep 1. This is 9. And this is 2. That is our final answer is 692. That is in base 10. So we just converted 1264 in base 8 to 692 in base 10. For clarity, let's convert this 692 in base 10 back to its original form in base 8. Our answer must be the same as this if everything goes on well, if we solve it correctly. So let's get it done now. Yes, like I said, for clarity, so that we'll be sure that we know what we're doing, let's convert 692 in base 10 back to its original form, which is base 8. And let's see. So 692 using the long division method divided by 8, which is the base we are converting to. And we're going to record the remainder here. Now, that 692 divided by 8, this is how to do it. The first two digits we have is 69. So 69 divided by 8 will give us 8. because 8 times 8 will give us 64. Now, subtract 64 from 69. Then we have what? We have 5 remaining. So that's not the end. Don't forget we still have 2 here. Put that 5 at the front of 2. Put that 5 at the front of 2. That will be 52. Then 52 divided by 8. That will give us 6. 6 times 8 will give us 48. And subtract 48 from 52. Then we have 4. So that means we have remainder 4. Alright? 86 divided by 8. We have 10. And remainder 6. Then 10 divided by 8. We have what? We have 10 divided by 8. We have 1. Remainder 2. And 1 divided by 8 is not possible. That is 0. Then we have remainder 1. So we read from bottom to top. Then 692 in base 10 will have equals to 1264 in base 8, which is the same as what we converted. We converted 1264 in base 8 to base 10, and we convert 692 in base 10 back to base 8. So that is that about that. Conversion you might want to do from any base to another base, we pass through this process. When you are converting from any base, either base 2, base 3, base 4, or base 5, like I said earlier, whenever you are converting from any base to base 10, you take this process. And when you are converting from base 10 to any other base, you follow this process. Now, let's solve an example whereby we won't be dealing with base 10 and we won't be dealing with base 2. I want to convert from 2 different bases that doesn't involve base 10 or base 2. Let's solve this example. We have to convert from base 3 to base 8. We have to convert 211 in base 3 to base 8. As for me, I always love to be descriptive in my solution so that anyone that wants to assess my work will find it very clear to assess. So the first thing I will do is, firstly, I'll let you know what I want to do. Convert 211 in base 3 to 10. That is how to approach this kind of question. When you have to convert from one base to another, which doesn't involve 10, you firstly convert the original number from the original base to base 10. And you now convert the base 10 equivalent of this number to the destination base, which is base 8. Now, let's see how it goes. Don't forget the procedure we do follow. That will be, you now pick this number one after the other. 2 multiplied by the base, which is 3, and raised to power. Don't forget, like I told you, it's not necessary that you put it as long as you know what you are doing. But for benefit of those that hasn't understand yet, we are to assign power to each of these numbers, starting from 0, 1, and 2. And this will now be raised to power of 2 plus 1 times the base, which is 3, raised to power of 1, then plus 1 times 3 raised to power of 0. Then is equals to, we have 2. 3 raised to power 2. That's 3 times 3, and that will give us 9. Plus 1 times 3 raised to power of 1, that is 3. And plus 1 times 3 raised to power of 0 will give us 1. We have 2 times 9, that is 18. Plus 1 times 3, that is 3. Plus 1 times 1, that is 1. So let's do the arithmetic. 18 plus 3, that is 21. Plus 1, and that is 22 in base 10. Now we just convert 211 in base 3 to base 10, which is 22. Now, moving forward, we have to convert this base 10 equivalent to base 8. So then convert 22 in base 10 to 8. All right. So don't forget the long division method that we do follow. You divide this number by the destination base, which is 8. Then you record your remainder here. 22 divided by 8, that is what? 2. 2 remainder 6, because 8 times 2, that is 16. 22 minus 16 will give you 6. And 2 divided by 8, that's impossible. It's 0, then remainder 2. So you read from bottom to the top. That means 22 in base 10 will be equals to 26 in base 8. 22 in base 10 will be equals to 26 in base 8, which implies that 211 in base 3 will be equals to 26 in base 8. It is as simple as ABC, even as simple as eating rice and beans. So, as you can see, any conversion operation you want to perform across all number-based systems will follow these two procedures. Either you are converting to base 10 and you are converting from base 10. You follow either of these two procedures to achieve your results. Now, we come to the end of the part 1 of the number-based system for today. The part 2 of this video will be talking about how to perform basic arithmetic operation across all number bases. That is multiplication, division, addition, and subtraction. But before we go, I would love to give us an exercise. Convert 1101 in base 2 to base 5. So I want to see how many of you will attempt this question and get the correct answer. So comment your answer. Put your answer in the comment below. And let's see who's going to get it right. And don't forget to subscribe to our channel and ring the notification bell so that you can receive updates about our next video as we continue to solve mathematics problems from the basic to the advanced mathematics. Don't forget to follow us on our social media platform. We are on Facebook, we are on Instagram, and we are on TikTok at IntelliMaths Pro. So have a nice time. See you in the next one. IntelliMaths will help you develop intelligence for mathematics.